I want to show you some 12 basic rules that you can apply when solving indices problems. Let us begin immediately. Rule number 1. N to the power of A multiplied by n to the power of B is the same thing as n to the power of A plus B. An example is 2 to the power of 3 multiplied by 2 to the power of 2 is exactly the same thing as 2 to the power of 3 plus 2. And this is 2 to the power of 5, or you can simplify it as 32. Example number 2, or rule number 2 rather. N to the power of A divided by n to the power of B is the same thing as n to the power of A minus B. An example of this is 3 to the power of 5 divided by 3 to the power of 2 is the same thing as 3 to the power of 5 minus 2. When further simplified, this is 3 to the power of 3 and it can be written as 27. This is the answer. Rule number 3. Rule number 3 states that n to the power of A plus the bracket all to the power of B is the same thing as n to the power of A times B, which can actually be expressed also as n to the power of AB. How does this apply in indices? Let me give you an example. In brackets 2 to the power of 2 or 2 squared all raised to the power of 3 is the same thing as 2 to the power of 2 times 3, which is exactly the same as 2 to the power of 6. And when further simplified, this can be written as the number 64. This is how this rule applies. Let me show you number 4 rule. The fourth rule of indices gives us that m and n all to the power of A is the same thing as m to the power of A times n itself to the power of A. How can you apply this? Take an example as 2 times 3 all to the power of 2. This is the same thing as 2 to the power of 2 multiplied by 3 to the power of 2. This is the same also as 2 squared is 4 multiplied by 3 squared is 9, which is the same as 36. This is how you can apply. Rule number 5. The fraction m divided by n all raised to the power of A is also the same as m to the power of A divided by n to the power of A. How can we apply this? Let's apply it immediately. 3 divided by 4 all raised to the power of 3 is the same thing as 3 raised to the power of 3 divided by 4 raised to the power of 3. If we further simplify this, 3 raised to the power of 3 is 27 and 4 raised to the power of 3 is 64. This is our answer. It's as simple as that. Now, what is rule number 6? Rule number 6 is what I call the negative power rule. N raised to the power negative A can be expressed simply as 1 divided by n raised to the power A. A simple example is 4 raised to the power negative 2 is the same thing as 1 divided by 4 raised to the power 2, which when simplified is going to be 1 all over 16. Now, let's look at rule number 7. Rule number 7 says that the square root of n can also be expressed as n to the power of half. An example is the square root of 4 is the same thing as 4 to the power of half, and 4 to the power of half, as we know, is 2. It simply means the square root of 4. Now, let's dig in a little further. Rule number 8. The 8th root of n can also be written as n raised to the power 1 over a. Note here that a is never equal to 2. With that in mind, let me give you an example. An example is the third root of 27. This can further be expressed as 27 raised to the power of 1 over 3. And as we know it, the third root of 27 is exactly the same thing as the number 3. This is our answer. Okay, I think I should change my color this time around so that my ink can change. Now we go to rule number 9. Rule number 9, let's use the bit root of n all to the power of a. Or this can actually be written like this with a bracket the bit root of n, close the bracket, all to the power of a. An example is the third root of 8, all to the power of 2. So let's close it in a bracket and square it. As we know, the third root of 8 can actually be written this way. Now, we can further simplify this rule as exactly the same thing as n raised to the power a divided by b. So for the third root of 8 raised to the power 2, this is exactly the same thing as 8 raised to the power 2 all over 3. And as we know, the third root of 8 is 2. Then this is now going to be 2 raised to the power 2. And 2 raised to the power 2 is equal to 4. Did you get that? Alright, we have just a few more to go. So let's proceed. Rule number 10. Rule number 10 is what I call the negative fraction power. N raised to the power negative a over b. This is further expressed as 1 divided by n raised to the power a over b. Let us show an example. Imagine having 27 raised to the power of negative 2 over 3. How would you solve this kind of problem? This is exactly the same thing as 1 divided by 27 raised to the power 2 over 3. Let's try solving this problem and see how we can actually simplify it. The numerator remains 1. Now the third root of 27 is 3. Remember the 2 power, that is 3 squared. So our final answer is going to be 1 all over 9. Just like that. Alright, the two remaining rules are what we call the special rules of indices. Rule number 11. Rule number 11 states that any number to the power of 0 is equal to 1. But note, in this case, the number must not be the same number as 0. Let me give you an example. 5 to the power of 0 is the same thing as 1. Yes. 2 to the power of 0 is the same thing as 1. Yes. 100,000 to the power of 0 is the same thing as 1. It's as simple as that. But most importantly, the number must not be 0 to the power of 0 because that doesn't work here. Did you get that? And finally, another special rule of indices. N to the power of 1 is the same thing as n. In fact, we usually do not show the number 1 when we're writing numbers. For example, instead of writing 5 to the power of 1, we simply write it as the number 5. It's as simple as that. Instead of writing 2 to the power of 1, we can simply write it as the number 2. This rule applies for every whole number as well, even 0 itself, because 0 to the power of 1 is also the same thing as 0. I hope you enjoyed our video today. Thank you once more for watching Whiteboard Math Party. Please give us a thumb up if you really enjoyed the video to encourage us to do some more. See you later.